This conference will now be recorded.
Hi guys, good morning. I hope you're able to hear me. Can
Yeah, hi,
anyone please confirm?
Hi, Bhaskar.
Hi. Yeah. So I hope you attended my demo session, right? Is everyone attended, or did you get a chance to go through if you are not attended? Okay. So even if you're not went through this particular demo session, that's not a problem. In that particular place, what we are going to discuss throughout the sessions that we discussed about it. So as a first session, I'm going to take you through, like, let's say for example, if I wanted to provide a solution for your big data, we need to have a big data solution services. So we are having a Hadoop, and we are not going to see that because that is completely on-premise since we are talking about Microsoft Azure. So Microsoft Azure, what are the services that we are having to provide the solution for your big data? So one is Azure Data Factory that we are going to say, and other is Azure Data Bricks we are going to use. So these two services will be used to provide a solution for your big data. These two services will be used to provide a solution for your big data. And this particular service will be used for handling structured and semi-structured data. And if we have a unstructured data, then we can use this Azure Data Bricks to provide a solution. I already told you Azure Data Factory is a cloud-based integration services that orchestrates and transforms the data from various data sources to cloud resources. So we can take this a notebook from the Azure Data Bricks to Azure Data Factory to make it orchestrate. So we can make we can integrate in the Azure Data Factory itself. So how we are going to call your Databricks notebook into Azure Data Factory, that we are going to say practically, so that you will get better clarity. Now, we know these two are the main services for the data engineering that we are going to use, and we need to know how we can have a source for this particular services, and we need to know how we can have a destination for these two services. So what are the services that we are going to have it? So in this particular place, we'll be having a different kind of data sources. So whatever is there in this particular side, left side, that we can call as a OLTP system. So I wanted to take you through the differences between OLTP and OLAP systems. So previously we used to have a OLTP system, and even now also we are having still OLAP systems. The only thing is we used to store the data into the data warehouses when you go for the traditional ETL tools, but now we are not going to store the data into data warehousing directly. We are going to handle it in a different way. So
Hey,
traditional data
Bhaskar,
warehouse,
sorry, Bhaskar, is this session being recorded?
yes it is.
Oh, okay. All right. Thank you.
It is recorded. Okay, so because I'm not going to give any note for this. Not only this, all the recorded sessions you are going to get.
Okay, so all the recorded sessions will be provided somewhere online.
Yes, yes,
Okay, all right. Thank you.
yeah. So I'm just going to take you through that how it is going to be there. Like we have a like if we have a data, if you wanted to transform the data into information, definitely we need to save the data. So whatever the data is there in the first stage, that is a OLTP system. So this is going to have a data here. This data is completely raw data. So we need to save the data. We need to get the information on top of this data. So how we are going to get the information? When you have a raw data here, we need to transform it. So instead of directly transforming the data, instead of showing this data directly into the information, or instead of getting information directly from this data, we need to transform this data. After transforming, then you'll be having a cleaned data here. So once you have a transformed data, this particular data, I just wanted to say transformed data. So since it is a transformed data, then on top of this, we are going to get the insights. So that insights we can call it as a information. So that insights we can understand. Insights can be used like charts, you can have it. So if you have a trends, then you can show the trends, and whatever the chart the reporting team is expecting, they can show as per their business requirement. So in order to visualize the data in the visual, we need to have a transformed data. So who is going to give a transformed data to the reporting team, or who is going to give a transformed data to the downstream system is data engineering team is going to take care about it. So we need to bring the data in the whatever the data we are having here, a raw data. That raw data we are going to transform by using Azure Data Factory and Azure Data Bricks, and we can keep the data into somewhere. So I'll talk about where exactly we are going to keep it later. So at this point of time, your raw data is going to be transformed into cleansed data, or your raw data is going to be transformed into um, cleansed data. So once we have a cleansed data here, or once we have a transformed data, that data will go for the downstream systems, so to provide the information. So this is the OLTP system. Like OLTP system will be used for running the business. So wherever you're running the business, or the very starting data source for your system, or for us, as we are going to work as a data engineer, you will be having some source. That particular source we can call it as a OLTP system. So this OLTP system is a distributed system. Your underlying data sources are not at a single place. They're distributed into different platforms, or different operating systems at different places that we are going to have it. So when you have a distributed data, you cannot get the insights on top of it directly. That's not good practice to do it. So because of that reason, this downstream system, whatever the system we are having, a reporting system in the downstream, so they are going to expect the data at one place, or we have to keep it in a centralized location, so that they can easily get the data from there. So because of that reason, we are going to bring the data and keep the data at one place. Okay, so like if I say example for this is uh, the data example is collection of numbers representing temperatures recorded over a month is a date. So whatever the temperatures we are collecting every day for a month, we are collecting every day, and all this we can treat that as a date. As a data we can treat. If I wanted to say what is the maximum temperature out of all these 30 days, or if I wanted to say what is the average temperature out of all these 30 days, then we can say that is information. So getting average temperature from all these 30 days, we can call it as a information. So how we are going to get is after bringing all together at one place, we can get that particular insight from this particular data. So information is something different, and data is going to be something different. So information is always going to be useful to take the decisions against your business. So you can solve your problems, so that you can grow in the business. So that is what about the information. So for that reason, we need to transform the data into information. Why we are going to transform the data is because to provide the better information to the customers, we need to transform, and this transformed data we need to give it to the downstream systems. And let's talk about even OLTP and OLAP systems. OLTP is specifically designed for running of the business. Okay, so how they are going to running, we are not going to worry about it, because we are not going to be part of it. So when you order a product with anything like Amazon or Flipkart, your order is going to be captured, and your order details are going to be stored in the database. In their database, it is going to be stored. So that means they're storing the order details or transaction details in the business system. So that business system is known as OLTP system. So wherever you're having a business underlying data, that systems we can call it as a OLTP systems. So we can do many operations that we can do it here. Like we can have a real-time processing, normalized data structure. Like we can, the way they're going to build this system to handle the normalized data, they're going to handle it. So there will be many tables, entity relationships, they're going to have it. Okay, so tables are going to have a relationships like anything, and hundreds of tables are going to be there as part of OLTP system. Again, all this design, we are not going to be part of it. I'm just giving an idea. If they ask what is OLTP system, there is a chances to ask when you go for interview. So because of that reason, I just wanted to take you through few things as part of this OLTP system. So simply I can say OLTP system is specifically designed for running of your business, and real-time data is going to be there as part of the OLTP system. And whatever the data is there in the OLTP system, that is not going to allow any duplicated records, because they designed in the way to handle duplicate record, unique records. So to keep the records, to keep unique records, they're going to design it. So that is not going to allow, the design itself is not going to allow any duplicated records. So how they're going to handle this? They're going to normalize the data. So they're having different kind of normalization forms. So ignore about it. I just wanted to say OLTP system will not allow any duplicated records. And you can access this OLTP system concurrently. So at one set, multiple inserts will go, updates will go. Okay, so reading is not going to be happen frequently in general, because that is a system which is specifically designed for business process. So for that reason, the reading is not going to be happen frequently. And you will be having primary key and foreign key relationships, as I already told you. This is going to have a hundreds of tables and having relationship, entity relationship, ER modeling, we can call it as. By using ER modeling, they're going to design, the database developers are going to design this particular system. An example for this is any business system. You can take whatever the business you're running, and what if you're, when you're taking a transactions, definitely that is a business system, or that is a OLTP system. Examples is customer relationship management systems, or e-commerce databases, banking systems, inventory management systems, so point of sale systems. So the initial stage of the database are, if when your application is going to take transactions and feeding the data into a database, that particular database we can call it as the OLTP databases. Next is OLAP databases. So why we are going to use this OLAP databases? Your OLTP system or OLTP databases are, they are not going to allow any historical data. They are going to have a current data. So they can maintain history not more than 6 months as part of this. Okay, so they are not going to have much more data here. If I need last 10 years of data to compare or to see some details, then definitely this system is not going to help us to have it. So for that reason, we are going to use the OLAP databases or OLAP systems. So this system is specifically designed for analytical processing. This system is specifically designed for analytical processing. The reason is this system is going to allow us to keep the duplicated records. If I have a, if I'm changing my address from like every quarter or every year, if I wanted to see what is my address 5 years ago, that records we cannot find in the OLTP system, whereas in the OLAP system you can find that record. How we are going to handle this SCD slowly changing dimensions, we are having it. So that is going to be possible to handle it as part of the OLAP databases or OLAP systems. And not only this, like you will be having data, the granularity of the data in this particular system is very leaf level, but it doesn't mean that we are going to have the same level of granularity in the OLAP systems. We'll be having different level of granularity. So in order to change the granularity, we need to talk about the aggregations. That means this particular system is going to have aggregated data, whereas in a OLTP system we are not going to have it. we can have a aggregated data as part of this. So when you have a aggregated data, that will be easy for doing the analysis. You can have a less amount of data and less volume of data, we can keep it. Of course, it is having duplicated data. When you compare with this, there is a like millions of records you're going to have it. Apart from the normal fact tables, you can also have a aggregated fact tables as part of this. And this system, whatever the data is there in this system is transformed data. How you are going to bring into this particular system previously is, we have a SQL Server integration services, we have a Informatica, and we have a data stage. There are many ETL tools for there. Okay, so we can use all those tools to bring the data from your OLTP system to OLAP system. I'll talk about, even still we're having this OLAP system, still we're having OLTP systems in the market. The data sources remain same, but how fast you are going to process it. So previously, like when I worked even with SSIS, when I run a job on periodical refresh, so when I run this job, it may take even a days also. I came across even presently also we are having MSBA project like SSIS for extraction. So one of the job is taking more than 32 hours. So if it is taking more than 32 hours means we need to reduce the time. So how we can reduce it? We are trying to reduce within the SSIS. We are not yet started migration of SSIS project into Azure Data Factory for one of the project. Okay, so if we can give the same work to Azure Data Factory, it finishes faster. So how it is going to finishes faster, we'll talk about it. And these traditional ETL tools are not having more number of connectors to extract the data from the data sources. Whereas in the new traditional tool, new services we're having, if we take Azure Data Factory, we're having more than 100 connectors to extract the data from the data sources. So this SSIS also is coming from Microsoft, but still there is a less connectors is because we are having more connectors with Azure Data Factory. The purpose of this Azure Data Factory is to handle big data processing, whereas this SSIS is just transformation tool. If you have a less volume of data, then you can do it. If you have a more volume, it is going to take more number of hours or more number of days also. So there will be some jobs that used to take more than 1 week also. They used to go and run, keep on running to finish their job. So all these ETL tools we can use to bring the data into the OLAP systems. Whatever the data is there here, that data is a cleansed data. Whatever the data is there in that particular place, that is a cleansed data. So since it is a cleansed data, we can go for doing analysis on top of it, and data is going to be normalized, sorry, denormalized. It is denormalized means the process of maintaining the duplicates. We can have a duplicated records, all the transactions from the beginning till current stage, it is going to have it. Okay, so we can integrate the data. So your OLTP system is distributed with multiple systems, something like this. It is distributed. When it comes to here, it is going to be integrated. I mean to say, there will be only one target, but your OLTP system is going to have a distributed database, a distributed system. You may have a business data here, you may have a business data here or here, but when it comes to here, we are going to integrate, we are going to consolidate, and we are going to keep it at one place. That is about the data consolidation. And multidimensional analysis is, we can provide this data to the multidimensional cubes, and you can slice and dice the data by using multidimensional cube and even a tabular models also. For tabular models also, we can provide the data from this particular systems. So OLAP systems will be used for doing the data analysis. If you wanted to analyze your business data, then we are going to use that. Now, I wanted to give a difference. Why we need to go for out of this traditional ETL tools. So as I said, to move the data from OLTP system to OLAP system, we can use the traditional ETL tools also. You can use the traditional ETL tools. But why we need to go for cloud? Why we need to travel towards to the cloud? So in order to know that, let me talk about first what is on-premise. So when you go for on-premise, we are having a lot of issues. So to avoid those issues, we are traveling towards to the cloud platform. So when I have a on-premise refers to the traditional approach of hosting and managing IT infrastructure. So everything will be taken care by yourself. You need to have your own infrastructure and you need to have your own software within your organization. And softwares within the organization's own physical premises or data centers. So you can have your own data center or you can have your own premises to have all these things. So that means you need to take care your infrastructure and you need to take care to install all this infrastructure and you need to take care about the software installation, setuping, networking, physical security and cooling systems, power systems, all those things you need to take care about it. So everything will be taken care by yourself. So it's own property. If it is on-premise means that is your own property that is going to be taken care by, everything can be taken care by yourself only. So when you have a on-premise, the organization's IT team is responsible. That means your team is responsible for managing and maintaining the infrastructure. So not only that, including hardware provisionings, if we need some hardware, if you wanted to add the hardware, if you wanted to add the compute power to your existing systems, then you need to take care. You are the responsible for that. And software installation, updates, security and backups, everything will be taken care by yourself. So I don't want to go, like there are many companies, they are not ready to go for own infrastructure. And even the bigger companies also, they're not using their infrastructure is because using the infrastructure, they're going to invest a lot of amount for investment, a lot of amount for infrastructure. And apart from that, so it takes longer time to set up everything. In order to set up on-premise environment, it's going to take a number of months. So to avoid this, if you wanted to provide the solution faster and if you wanted to decommission your infrastructure right after completion of your work, then the better choice is cloud computing. If you go for on-premise, if you have your compute power, you cannot throw it. So you need to use it. Whether you are having a project or not, you need to have your own infrastructure if that is the on-premise. But if it is a cloud computing, right after my big data processing, right after completion of my project, I can take it out. I can reduce the compute power. Okay, so here it is not possible. Once you buy it, it's your own, whether you use it or not. But when it comes to here, it is something like different. The same thing, the same work I wanted to do it with cloud computing. So what happens if I go with the cloud computing is everything will be managed by cloud vendors. So we are having many cloud vendors in the market, and the topmost cloud vendors is Microsoft Azure and AWS, and now even Google platform also we are having GCP. Okay, so when you have this cloud, we can use the services from the cloud computing. We can take the service rent. We can rent a service from the cloud platform. So what are the uses of this? We don't require to invest on infrastructure. We don't require to update any softwares. It's all depends. Okay, so if my requirement is demanding to have their infrastructure, but I wanted to have my own installation, then you can also go for that. So we need to buy a virtual machine. Okay, so virtual machine you can take from there, and you can have your own operating system also. So I'll talk about this little more details when I'm going to talk about what kind of different services we're having, like SaaS service, okay, and PaaS service, and IaaS service. So when I'm going to talk about them, then you can have a more clarity where exactly we are going to have a IaaS and where exactly we are going to use the PaaS and where exactly we are going to use the SaaS that I'm going to take you through that. So the advantages of this cloud computing is the scalability. Okay, so if I wanted to increase the compute power, I can increase the compute power. I can scale up. Within just few minutes, I can scale up, and within the few minutes, I can scale down also. So that feature is not that easy to do it in on-premise, and it's a cost effective also. But here we don't require to have that kind of things. So cloud services provides the flexibility to easily scale up or down computing resources based on demand. For this one, I'll give one of the example that I experienced in my project, so that you can have you can understand when I'm going to talk about the SQL Server. I'm going to talk about this particular scalability, how exactly we are doing it, and organizations can quickly allocate more resources during the peak usage. When you have a peak usage, then you can increase the compute power and scale them down during periods of low demand. If you're not having in demand, if you're not required, then you can down it. If you don't down, then again you have to pay the cost. So this Azure solution architects are going to always think about how we can reduce the cost. So this is again, it's not our job, but I just wanted to say, as a data engineer, we need to know few things, even if it is not related to us, but we are going to participate in some places, in some areas. So when we can go for scale up and when we can go for scale down, I'm going to talk about it. And cost efficiency. The cost efficiency is, we are going to have a pay as you go model for cloud cloud computing. So for whatever we use, for that only we are going to pay. If we use for 1 hour, we are going to pay for 1 hour. Okay, so there are some services, monthly based services also we're having, but most of the services we are going to have pay as you go model. Okay, so we don't require to pay for upcoming or upfront infrastructure investments. We don't require to pay it here. So right after 1 week, I wanted to increase the compute power. You can increase it. Okay, presently we have a 5 compute nodes, and after 1 week I wanted to go for 5 more. Then first 1 week you are going to pay for only 5 computes only. You are not going to use it for this. And if you if you can pass this particular compute, then we don't require to pay huge amount. So there are different kind of pricing tiers or different kind of purchasing models that we are going to have as part of cloud computing. So it's vendor to vendor is going to be different, but in most of the places we can say less cost when you compare with on-premise. So that is about this cost efficiency and global accessibility. You can access from anywhere. You can access from any region. So that is one thing that we are going to have, and agility and speed. So we are going to have a cloud services enables organizations to rapidly provision and deploy resources, applications and services, reducing the time required for infrastructure setup and software development. That means if I wanted to set up your Azure Data Factory, it just max 2 to 5 minutes we can use to make it available. So to start your everything, max to max within the 1 week we can do it. We can do prior that also, because the reason why I'm saying this 1 week is we need to have a appraisals, we need to have a permissions and set up everything. To start the development within the 1 week we can do it, but if you go for on-premise, it takes months to start your project. So 1 week is very less time. In some places, if everything is done, if it is a small company, we can start in the day one itself. Okay, so that much fast we can set up it. So that is not possible with on-premise. And resilience. That means like if you wanted to maintain the redundancy, if you wanted to keep the same file in a different places in an on-premise, it's a very huge cost when you go for this redundancy. So duplication of the file. So how many times you're going to have the same file? So generally in by default we are going to have it 3 times. When you have a file 1.txt, this 1.txt is going to have in is going to store in 3 different places. If you save the same thing with on premise, then you need to have a lot of storage, right? So when you go for when you go for cloud platforms, you're having a different kind of synchronization options. We're having, we can reduce the size of the data. We have a different kind of file formats we're having, like Parquet file format is one of the trending. It's a free where it is, and this is going to reduce the size of the file is like more than 70 or more than 70% as we can reduce with Parquet file formats. Okay, so I'm going to talk about this, and very frequently we are going to use this. The reason why we are going to handle the redundancy is because if any of the location is damaged, if the any location is affected for some reason, then you are going to lose the files, or you're going to lose the data if you're having on premise. But when you go for cloud platform, we can handle it. We can keep this file within the zones, or within the regions. I mean to say hundreds of kilometers away, we can keep your same file. If at all, if this entire region is going to be affected, that is going to be available in the secondary regions. So I'll talk about how exactly they're going to handle the redundancy as part of Microsoft Azure. I'm going to take you through that. And the sixth one is very, very important. That is managed services. If you go for on-premise, if you have a SQL server, you have to manage. It's your own on-premise system. So you need to install it. You need to make sure is that running or not. You need to make sure is that in upgrade or not. Everything you have to take care about it. That means you need to manage your service. When it comes to the cloud, there are many managed services. So 80 to 90% of the services are managed services only. We don't require to install anything. We don't require to have a operating system. We don't require to set up anything. Everything will be managed by cloud vendors. So because of that reason, we can say most of the cloud services are managed services. So cloud provides offers a wide range of managed services such as databases. If I need a database, I don't require to install it. I don't require to upgrade my database. Always they're going to take care about it. And machine learning services, analytics services, security and monitoring, all these things will be managed services only. So these services reduce the burden on organizations IT team, because this is going to be really, it is going to reduce many things. As a cloud provider handles the management and maintenance tasks. If there is any upgrade from SQL Server 2019 to 2022, they will take care about it. Always it is going to have managed services, always going to have the latest versions. So that is about this managed services. So these are all the features of cloud computing. If you go for cloud computing, we are going to have all these features. So types of vendors, I'm just giving an idea here. Amazon Web Services, AWS. They're also providing managed services. They're also providing IaaS services, PaaS services as part of their cloud platform. So one of the best vendor is Amazon Web Services. So this is going to provide wide range of services that includes compute power. If I wanted to buy a virtual machine, I can buy a virtual machine. Whatever the operating system I required, I can take a required operating system with inbuilt, or you can directly go and set up your own operating system within the virtual machine. And storage also is going to be provided. When you're creating virtual machine, means we need to have a storage. And not only this, The file storages also we are going to have as part of their systems. Databases, networking, analytic services, machine learning services, all the services are going to be provided by Amazon Web Services. So Amazon Web Services is one of the cloud vendor, and the one more topmost cloud vendor is Microsoft Azure. And Microsoft Azure also provides the cloud computing. They're also providing cloud computing and provided by Microsoft. Microsoft Azure means Azure is coming from the Microsoft. So here also it offers wide array of services for building, deploying, and managing applications. So here also, if I need a virtual machine, I can buy a virtual machine, or if I need a storage, I can take a storage, and if I need a processing services, I can take a processing services. If I need a database, I can take a database. We're having wide varieties of services. I'm going to take you through how we are going to have it, how we can categorize different kind of services. When you compare with AWS, we are having more services in a Microsoft Azure, and Microsoft Azure is going to have a services with the user interface, with UIs. Okay, so coding is not required in many places in Microsoft Azure. So if you take Azure Data Factory, it is managed by Microsoft. It is a managed service, and we don't require to write a coding. So it is a code-free ETL tool. It is a code-free ETL tool. We are not having this kind of service in other cloud vendors. And the third, we are having a Google Cloud Platform, GCP platform here, and they're also having a similar kind of features they're providing in a different ways. So they are providing these services in different ways. So here also we can have a computing, storage, databases, machine learning, networking services, data analytics services. So by using this also we are having Databricks also they started providing the Databricks from this particular place. So Databricks here. Okay, so they added few more things in the Microsoft Azure to make it much more easier. Okay, so we are going to say practically how it is going to be there, because Databricks is not for any of this vendors software. It is a third party. The name itself is a Databricks. Databricks is associated with Microsoft, so they named it as Azure Databricks. And IBM Cloud is also there. They're also providing this IaaS services, PaaS services, and SaaS services. The way these three people are providing. But when you compare with the first two, these are having less services and less features when you compare with first. And we have a Oracle Cloud Infrastructure also with CI to have their own cloud platform, because Oracle is also one of the bigger organizations. They have their own infrastructure to provide to the customers. And Alibaba Cloud is also one of the cloud vendor. This is famous in the China. So they're also handling. 1 minute, please. So your Alibaba Cloud is also is one of the cloud vendors. They is to provide the cloud computing, storage, networking, analytics services, and they have their own services to provide solutions for their like for big data. And Salesforce is also one of the cloud vendor. Their main goal is to handle the customer relationship management CRM platform, and they're not into this kind of activities, but this is also one of the cloud. The topmost trending cloud vendors is Amazon Web Services and Microsoft Azure, and very soon we are going to be there in the first stage of the cloud platform, that is Microsoft Azure. So these are all the cloud vendors in the market. We're having it now. If I wanted to provide a solution for my big data, I have a big data. I wanted to process this data. I wanted to get, or I wanted to transform this data before getting the insights. So in order to process this data, I need to have a services. I need to take the services from the cloud computing or cloud platform. Whether you go to AWS or whether you go to Microsoft Azure or whether you go to GCP, we don't care about it. So I wanted to provide a solution for my big data. If I wanted to provide a solution for my big data, I need to take a service which is used to provide a solution for your big data. Okay, so there are multiple vendors out there. I'm going to take a service from the Microsoft. So if I wanted to take a service from the Microsoft, and Microsoft branding their services in the form of Azure, they're branding their services in the form of Azure and Office 365, and like this all SaaS services comes under the Office 365, like Office 365 services will be under SaaS service. Okay, so recently there is a drastical changes happened from Microsoft. It is under public review it is. So that is a Microsoft Fabric that I can say. There are a lot of changes happened, and for they brought all this like to provide the solution for your big data. Instead of having the managed service, we can also use a different kind of a service, that is a SaaS service, to provide the solution for your big data. And those services is not only for data engineering. We can use them for data science, we can use them for machine learning, we can use them for even Power BI also. So whatever, I wanted to take one of the service to provide to provide a solution for my big data. So that service is available in the cloud. That service is available in the cloud. Let's say, since we are talking about Azure Data Factory, I'm just going to take ADF. So Azure Data Factory, which is hosted in Microsoft Azure, it is available in a Microsoft Azure. Now I wanted to take this service. I wanted to take this service. So if I wanted to take this service, how we can take the service from here, we'll talk about it. At this point of time, to provide a solution for my big data, I need this service which is available here. So this is your system. Okay, so let's say, for example, I wanted to say this is your system. So your system is going to take the service from the Microsoft Azure, or is going to take from the cloud vendor, any cloud vendor it is. So the process of taking the service into your system, the process of taking a service from the cloud into your system is known as a cloud computing. So cloud computing is process of taking a required service or required services. You may have a you may need a single service, you may need a multiple services. 100% multiple services are required for many projects. I didn't come across anywhere with single service when you go for when you're transitioning from your old approach to new approach, or from on-premise to cloud. When you moved, then definitely you'll be having more than one service. So that particular process we can call it as a cloud computing. Now again, we are having different kind of cloud computing, different deployment models we're having. One is a public cloud, private cloud, and hybrid cloud. I wanted to take a service from the cloud vendor, and this cloud is having three different types. So three different cloud deployment models. You can deploy into the public cloud, we can deploy your services into private cloud, you can deploy your services into hybrid cloud. When you talk about whatever we talked about, the top cloud vendors, the different types of cloud vendors, all those vendors coming under public cloud. So Microsoft Azure is a public cloud. They can give a service to you, they can give a service to the company also. To anyone can buy a service from the Microsoft Azure. Anyone can buy a service from the AWS. Anyone can buy a service from GCP also. So because all these vendors are public cloud vendors, and I have a private cloud also. This private cloud means They have their own infrastructure. Let's take, if we take a TCS, TCS have their own infrastructure. Just imagine. And even prior this cloud platform and all, we have a private cloud only. So one customer is, let's say you are the customer, and you have you have a requirement to transform your business data into information. So for that reason, you are going to connect with the TCS, and they're going to you're going to take a service from the TCS. So this is a service based company. There are many service based companies. If it is a small company, they're going to take a infrastructure from somewhere else like TCS or someone else. But just imagine, this individual may go to the TCS, or small company also may go to the TCS to take the infrastructure, because as a small company they are not ready to handle all this infrastructure. So they have a infrastructure, but they don't give infrastructure to any individuals. They will give a infrastructure to the companies. Okay, so if I wanted to take any service, they're not going to give any service to you. They're going to give a service to the company. So that means they're going to give it to the selected people, not for everyone. So whatever the infrastructure they're having, they're also going to have a virtual machines. They're also going to provide the database. The only thing is the fixed price will be there. So you'll be having fixed contract yearly, how much you're going to pay, what are the services, or how much compute power. So all those things will be decided by TCS in this particular thing. I just wanted to say. So those kind of environment, or those kind of vendors, we can call them as a private cloud vendors. And hybrid cloud vendors also we are having it. So what does it mean, this hybrid cloud vendor is? So there is a one customer, and there is to the TCS, and they're asking to provide the solution for their particular data. So what happens is, they have a limited budget, or they're not having that much budget to have complete private cloud. Okay, if they go for private cloud, they're having whatever they're expected, it is crossing their budget limit. So if that is the case, then definitely they're going to think in a different way to reduce cost cutting. At the same time, this TCS is going to say, if you're having this kind of situation, then we can go for public cloud to provide the solution. If you go for public cloud, the cost is less when you compare with the private cloud. Okay, but this person is not interested to move completely to public cloud. So at some stage, TCS or these people are going to be convinced to have few things in the private cloud and few things in the public cloud. Okay, so whatever they feel, okay, that's fine to keep it in a public cloud. So those kind of services, they're going to take it from the public cloud. And whatever they feel, okay, this is a little critical, I'm not interested to keep it in a public cloud, then they can go for private cloud. So do not worry about keeping data into the public cloud 100%. There will be multiple levels of security. Even to access your Azure Data Factory as a developer, it's not just like username and password. There are different levels of securities they're going to provide it. So we can believe public cloud, we have a different kind of securities, and even you're not going to know, or you don't know where exactly your data is stored, or you don't know where exactly your data is residing. So they're just going to say that a region. So when I say region, South India, or Central India, you don't know where exactly they're storing it. Okay, so you cannot even identify. So that much security it is going to be provided by the cloud vendors. So depends on the budget, they're going to decide to travel with public cloud plus private cloud. If you have a combination of these two, then we can say it is a hybrid cloud. So this is the different kind of cloud deployment models we're having in the market. And 99% we are going to use the public cloud is because it is going to reduce the cost like anything. Okay. Any question as of now? Okay, so when you go for Microsoft Azure is offering wide varieties of services. We have a compute services, we have a storage services, networking services, database and analytics services, AI and machine learning services. So developer tools, DevOps services we're having. So let me take you through like how exactly it is going to be there. Let me check here. I'll take you through all these navigations later. You can see here categories of this analytic services we're having, compute services, containers, databases, DevOps services. So whatnot. There are many services provided by Microsoft. So Microsoft having their own services, they're also selling third party services also. If you take a ADB, ADB is not Microsoft own service. Okay, so they integrated with Databricks and they made it as Azure Databricks. Okay, and Snowflake also you can take it from here. Okay, so many services that you can take it, even third party services also you can take. So they categorized. If I need a virtual machine, you can go for compute. If I need a data factories, then I mean to say analytic services, you can see all these services are analytic services, big data processing services, data exploration services, we are having it. So you can see here analysis services, data lake analytics, it is going to be duplicated. Azure Databricks, data factories, data lake storage and one, it is also going to be duplicated. HD insight clusters, all this comes under big data processing services or analytic services we can say. Databases, we have a Azure SQL databases, Cosmos databases, open source databases we are having. A PostgreSQL is open source database. Okay, and there are many things that we are having it. And integration services we are having to integrate it. We are having storage services to store your data. So different kind of services we are having as part of Microsoft Azure. So all these services are categorized into three types. Whatever the categories that I have shown here in this particular place, I categorized right. All these services are categorized into IaaS services, PaaS services, and SaaS services. So you will be having three services, three types of services will be from the Microsoft Azure. So IaaS means infrastructure as a service. So when we can go for infrastructure as a service, we are going to talk. And the next service is platform as a service, PaaS service. Most of the services as part of data engineering is PaaS services. And third is software as a service. Software as a service, even now for data engineering, we have a SaaS service. That is Microsoft Fabric. Okay, so Microsoft Fabric will be used for even SaaS services also for data engineering. Okay, so I'm stopping here. I'm going to talk about this services when we can go for IaaS and when we can go for PaaS and when we can go for SaaS services. And then I'm going to talk about the storages. What are the different storages we are having? If you know the storages, then you can understand the processing. How we are going to do the processing. The processing is for ADF and ADB we are going to use to process the data. And here we have a storages like storage accounts, databases, and right after completion of the storages, we are going to start talking about Azure Data Factory and Azure Databricks. Okay, so these are all just for information, whatever we talked about it, how exactly we are having cloud vendors and what kind of services we are going to get, what are the benefits that we are having that we discussed till now. Okay, so I'm stopping here. If you have any question, you can ask me. Okay, then if you're not having any questions, we'll meet you on tomorrow. Thank you for joining.
Hey, Bhaskar, how will we get the link for recording?
Career IT team, you can check with them. The people who are talking with you, you can directly ask them. They will help you to get it.
Oh, okay.
Okay. Okay, then let's see you on tomorrow. Thank you for joining.